Good morning. Today we are going to be talking about vectors. We're going to start our vector valued functions and look at the calculus of vectors will be fun. So before we begin, let's do a warm up and let's review. So hit pause and try this problem and then we'll come back and work on it together. When I'm looking at polar graphs, I like to see where it's going, what direction it is, kind of give me a picture of what should be happening. So I can look up my bounds of integration and all the other things that I need. So the first thing I like to do is to make just a brief table of values. And you don't have to do this. This is really more for me, just to be able to visualize it. So if I try 0 in that problem, the sign of 0 is 0, so my r would be 2, which that would put me at the point right here, 0 or 2, 0. And then if I keep going, if I try, for example, pi over 2, and I plug pi over 2, I would get negative 2, which gives me my point right here. So pi over 2, negative 2 is that point right there. And then I could keep going. But notice that the point that I'm looking for to be able to find my area, the point that I need this point. And since that wasn't given to me initially, and this is really all the amount of the curve that I have, I am going to solve for that bound of integration. And I'm going to say that 0 equals 2 minus 4 sine theta, which means that 1/2 equals the sine of theta, which means that theta equals pi over 6, theta equals 5 pi over 6, etc. But we're really only concerned about the pi over 6. So then this would be the point here, would be the point pi over 6, comma 0. Okay, well now that I know my bounds of integration, to be able to find the area should be pretty easy. And I can go through and do area equals 1/2 the integral from 0 to pi over 6 of 2 minus 4 sine theta squared d theta, and then type that in my calculator. So here I get that the area is, let's do approximately 0.3377. How'd you do with that one? Okay, so the next part asks you to find the equation of the line tangent to the graph at pi equals 0. Oh my goodness, that says theta equals 0. So the first thing that I need to do in order to find my equation is I need a slope and I need a point. So let's go through and find both the slope and the point. Well, to do that with polar, remember we are going to find the slope, which we are going to call dy dx. And dy dx is dy d theta over dx d theta. And so therefore I need to go through and find dy d theta and dx d theta. But before I do that, I need to figure out x and y and use what x and y equals. So I know x equals r cosine theta. So I'm going to plug that into my equation up here. Or I'm going to plug my equation in rather down here. So I get x equals r, which is 2 minus 4 sine theta cos theta. And then I'm going to take the derivative with respect to theta of this problem. And when I do that, I'm going to get the derivative of the first, which is going to be negative 4 cos theta times the second plus the derivative of the second. Derivative of cosine is negative sine, so let's change that to a negative. I'll just do negative sine theta times the first. Now, this is going to be the slope at when theta equals 0. So I'm going to evaluate this when theta equals 0. And doing that, plugging that in, I'm going to get negative 4. Now I need to take and do the same thing. Let's change colors so it's easier to see. I'm going to do the same thing with the fact that y equals r sine theta. And then y equals 2 minus 4 sine theta sine theta, and I'm going to take the derivative of y with respect to theta. And doing that, I get the derivative of the first, which is negative 4 cosine theta, times the second, sine theta, plus the derivative of the first, I'm not sure why I switched the order on this one, sine theta times the derivative of the second, which is cosine of theta. And this is going to be evaluated when theta, I'm too close to the bottom, equals 0. So theta equals 0, and when I do that, I get 2. Okay, so now I know that my slope, my dy dx, which is dy d theta over dx d theta, is going to be 2 over negative 4, or negative 1/2. So I have my slope, and then I need my point. Okay, well, the point that I have is I can go back into the x equals r cos theta or the y equals r sine theta and plug that in. And when I do that, if I do x equals 2 minus 4 sine of 0, cosine of 0, we get x equals, oh, that was supposed to be a 0. So we get x equals, cosine of 0 is 1, sine of 0, so we get 2 times 1, so we get x equals 2. And then let's do the same thing for the y. We have y equals 2 minus 4 sine of 0 times the sine of 0, so times 0. So we get y equals 0. So my point is the ordered pair 2, 0. And then my slope is negative 1/2. So then the equation is y minus 0 equals negative 1/2 x minus 2. How'd you do on that review? Okay, let's move on. All right, we are going to begin looking at vectors in the plane. And before we do that, we should be doing a review, theoretically, of stuff that you learned back in Honors Trig PreCalc with your vectors. So let's see how much is actually review. Let's hope all of it. When we talk vectors in the plane, there's several things we're going to look at, both the notation, we're going to look at the magnitude, direction, unit vector, hopefully jog your memory just a little bit, and then we'll move on to some operations dealing with vectors. So let's begin. First, let's draw a vector in this plane. So let's draw it right here. So this is 2 over this direction, and then 3 up, in case you can't tell what my intention was. And if we draw this vector, there's several different notations that can be used in vectors that we want to talk about. The first is vectors will either be notated in a textbook or online by either a pretty solid, like bold V, it's getting worse, something like that, or it could be notated with a V with a little arrow on it. It's like a one-directional arrow. It's not both sides. It just has one of the branches, like one of the wings. So like capital V with one arrow up top. So you could see that either way. Now, with vectors, vectors are typically labeled with V, U, W are the typical variables for vectors. V makes sense, obviously vector, but U and W are used as well. And with this notation, we could see that this is the vector 2, 3. We could see that this is the vector 2i, and I is used for vectors in 3j. I is used and j is used, and we'll talk about what that means. Or you could see the notation, the vector is, and it be in brackets that looks like this. Okay, let's briefly talk about the I and j aspect of this. I and j, that notation comes from unit vector notation. And in unit vector notation, let's just change color so you can see. In unit vector notation, the I is a vector that goes from 0, 0 to 1, 0. So I is equivalent to the points 1, 0. And then J is a vector that goes to 0, 1. And so therefore, when we say 2I plus 3J, what we're doing is 2 times the vector 1, 0 plus 3 times the vector 0, 1. And that's where we get 2, 3 from. So that's where that comes from. Now the magnitude. Magnitude can be notated several different ways, and it depends on textbook, depends on lots of things. You may either see a single bar, almost looks like an absolute value. You may also see a double bar used. But what the magnitude represents is the length of the vector. And the way we find length is using the distance formula roughly, but we take the I component and square it, and the J component and square it, and then we get a magnitude of root 13. Okay, and now moving on to direction, because that's what makes a vector a vector. A vector has a direction and magnitude. And so to find the direction, we're going to use trig, and we're going to use the idea that the direction comes from the positive x-axis. It's the angle made with the positive x-axis, or from the positive x-axis. And to find direction, I know that to find that angle, theta, is going to be the tangent inverse of my y component over my x component. So my j vector over my I vector. That was supposed to be j and I. Okay, so in our case, this direction would be the angle theta, would be the tangent inverse of 3 over 2. Now a unit vector, if you remember, the definition of a unit vector is that its magnitude is equal to 1. So the length of the vector is equal to 1 unit, thus a unit vector. And so if I am going to find the unit vector, the way I'm going to do that, the unit vector is going to equal 1 divided by the magnitude of the vector multiplied by the vector. Okay, so we've already found the magnitude of the vector we're looking at, and we know its points. And so if I want to find the unit vector of the one we're looking at, the example we're looking at, I would have the unit vector equals 1 over root 13 times the vector 2, 3. And so typically we would just write it as the unit vector equals 2 over root 13, comma 3 over root 13. And that would be my unit vector. Okay, let's keep going. All right, we are going to look at two operations dealing with vectors. First is scalar multiplication. So let's go back and use that same vector that we had before. That was 2, 3. So that is the vector right here. There's vector v. And if we wanted to do, for example, say the opposite of vector v, what would that look like? Well, we know that that negative would be multiplied by both terms inside. And so negative v would be negative 2, negative 3 would be this vector here. So this would be negative v. All right, what if we wanted to do 2 times the vector v? What would that look like? Well, when we multiply it, we would get 4, 6, because we multiply each term. And 4, 6 is off the graph by just a little bit. It would be this entire vector, including the vector v that we had originally. So that would be 2v. Okay. Now, adding looks a little bit different. Multiplying by a scalar seems pretty straightforward. But when we are adding, let's go back and put in that same vector. So let's put in the vector 2, 3. Okay, so my original vector 2, 3, if I wanted to add two vectors, so let's draw a vector W, and let's call it 2, 1. So that would be this vector here. This is W. What does it look like when I add the two vectors together? Well, algebraically, it's not that exciting, really, because if we do vector V plus vector W, we add each component separately. So we would add the 2 plus the 2 to get 4, and then we'd add the 3 and the 1 to get 4 also. And so when I look at this, if we look at vector V plus W, V plus W would be the vector 4, 4. Where does that come from if we look at it graphically? Well, if I were to pick up this vector W, and I were to take the initial point of it and the ending point of it, and I were to connect it to the ending point of my original vector V, so this would look like this, and I were to have the same magnitude and same direction. So remember, it's over 2 up 1, so over 2 up 1 would put me right here, and I would have that vector. So here is W when it's added on to V, and you can see that it creates this green vector here. I don't know why I can't seem to draw a straight line on the iPad, but I cannot. So V plus W is that vector right there. Okay, so last two examples. Try them, see what you come up with. All right, hopefully you had a chance to go through these. So let's look at them really quickly. We're going to look at them. Notice we were given two different notations for these vectors. So let's look at what that looks like together. I'm going to stick with one notation or the other, and you can do both interchangeably. I don't care which one you use. You can use either the angled brackets like this one has, or you can use the IJ notation, the unit vector notation, like vector V has. So it doesn't really matter. So if we want to find W, I know W is the U vector plus the V vector. So if I were to set this up, let's do the angled bracket notation. U is 5, -3, plus V is 1, 4. So my W then would be 6, 1. Now, if you were using the IJ notation, the unit vector notation, what that will look like is we will have the unit vector is 5I minus, that should be, minus 3J plus I plus 4J. And when I combine those again, you will get 6I plus 1J, or just J. So these two notations say the same thing. Okay, how'd you do? All right, finally, if we look at the last one, W equals 3U minus 2V, we would get W equals 3 times the vector 5, -3, minus 2 times the vector 1, 4. So we would get 15, -9, minus 2, 8, or plus -2, -8, either way. So 15 minus 2 is 13, and -9 minus 8 is -17. So in this instance, my W would be -13, -17. All right, how'd you do? Okay, so your assignment today is on WebAssign. It is 10.5a. Not too many problems, but have a go at those, and we will see you tomorrow.